I will just use the extra time.
So this is Marco.
Hello.
He's going to talk about open source EV charging.
Yes, thanks a lot. Yeah, I'm Marco. I'm part of the EVerest open source project, as I try to visualize here. And I would love to tell you about the issues in EV charging, what we try to do there with the open source project, and yeah, how we fix all these messy real world problems. So in principle, with all this energy transition going on, we want to electrify billions of cars in the world. So that's quite a lot. And if you look at the industry, there's currently thousands of different car types, and it won't get less. There's thousands of charging station types, backends, apps, whatsoever. If you just extrapolate, we will use billions of charging stations, and this is just an interoperability nightmare. We see maintenance issues in the field, we see stranded assets, and let's say software quality isn't where it should be. And what this picture visualizes, we have a combinatorial problem. Like if you have 1,000 car types, 1,000 charging station types, 1,000 backend system types, it's a billion combinations you have to consider when you test, and that's basically impossible. And there are really systems where you have to test every combination, or it would be better if you do so. So how do we address that? First of all, we could standardize all of this, then everything would be better. But as XKCD also pointed out, just adding more and more standards is not the solution here. So we should try something different. And what the EVerest open source project is doing is we try to have one software stack which solves and serves all the possible combinations here. So the idea is unifying that ecosystem with open source. And I guess my dear friend Achim is listening to this. No, I'm not saying everything has to be one open source project, but I think having 1,000 implementations out there is not solving the thing. So if we can dense it down to a few, would actually help quite a bit. And this shared investment is also freeing up resources for doing actual useful stuff instead of having the tens or hundreds implementation of a car interaction protocol. So what EVerest is technically doing, yes, we're Apache licensed software stack under the Linux Foundation Energy. We do all kind of interaction between cars, payment terminal, displays, backend management system, the power grid, either locally or remote. And so that means we have tons of different protocols to integrate, and we have a lot of state machine in the middle. And the problem is every charger looks different. So you have maybe single port home chargers, which are super dumb. You have public charging parks with a lot of different hardware configurations. How do you map that into one software stack? Yeah, we built something like a module framework where you can freely configure forever what you want to build out of that. So it can tailor the software to your hardware. So building block thinking. The problem with that, if you do that, so you enable a huge ecosystem of different players and vendors using that with their products, or being compatible, or building that into their products, and or using it in their chargers in the field. But you can't just cover that by simple unit tests of testing a single line or just making 100% code coverage, because you need something like scenario coverage, and then I'm back to the billion combinations. So I tried to map out with a colleague last week, so what is the stuff we're actually doing out there? So it's not just unit tests. We are going from best practices, Linux Foundation suggests that to us, like CI/CD, code smell, audits. We're doing all of that. On top of that, we try to implement each protocol as much as we can from both sides. So not only implementing the charger side of a communication channel, but also the car side. So we can at least test against ourselves. But if you test against yourself, you're also maybe talking bullshit to yourself. So we also need to test against third party. You need the system level testing, like having real hardware in the loop, having other third-party software, other third-party hardware in the loop in the testing. And really down to real-world feedback loops, like what happens in the field, is something happening there, what we maybe should think about, and even back to giving the feedback loop into standardization to maybe even fix the standards. So this slide will be a bit big. Let's see if that works. So typically, as one example, we're looking at three different entities. The charging station in the middle, car on the one side, and cloud on the other side. And one way everyone at the moment is testing is from the Open Charge Alliance. That's a Dutch non-profit which specifies the protocol between the charging station and the cloud. They built a test system, what they offer, unfortunately paid, for all their members and everyone else for testing this link. So they can either fake a charging station and talk to another backend system, or they can fake a backend system, talk to another combination of chargers and or cars. And that's nice and that's helpful. Together with an EVerest-based charging station, you can even use that for testing your car. What we're also now doing, because they have to test their testing system if it actually makes sense, if it actually does what it should do, they're cross-testing against EVerest. So every new release of this test tool is testing against us, and now every new release of EVerest is tested against their test tool. So in a way, it's called in their world golden system under test. So before they release their official certification tool, they're testing against our open source implementation, and before we will release something, we'll test against them, so kind of helping each other to up-level ourselves. And based on that, we meanwhile also offer kind of the same tooling as charging station car combination based on the EVerest open source stack for other backend systems, so they can test against that. And you can even think about combining those tools which are out there, like using an EVerest fake car together with this rich test set from the Open Charge Alliance to test charging station in the middle, just as black box test, or potentially also as white box test if you want to fake user interaction without actually pressing buttons. At the end of the day, we're also using EVerest quite successfully since a while with deploying some example chargers from Pionix or from anyone else, going after the car OEMs so they can test their prototype cars years before they're released to the public against that software stack, which is not just a dumb test system, but actually production code which will end up in the field. So with all that combinations, we try to bring open source and open standards into this as much as we can. And this virtual charger park is then basically a cloud service we built around EVerest in order to make it easier. But in principle, all the components are open source. There's description how to set up Docker containers with that. And you can see we also used Node-RED to build a small user interface for that emulated charger. But the good thing is all the logic under the hood between vehicle communication, power system communication, all of that is not faked, but it's the actual bits flowing just on a local host. What we also built in the EVerest community, or just starting to, because we realized testing is super hard. If the community builds a couple of test cases, there's always something missing. So one vendor suggested some months ago, like, could we do federated testing? So having a centralized system which is just saying, okay, there's a new branch coming in, and we want to test that against reality. How to do that? Yes, there are some EVerest internal test cases, but actually every vendor, every alliance can register as like, okay, please tell me when you do a test run. I will copy it to my proprietary system, do a test run with my commercial setup there as well, and then tell back to the community, oh, this is good or this is bad. So this way we can outsource the testing effort into the companies who use that code and don't break something there. We're also reducing the cost and the effort of the open source project and make it even more industrial usable. And everyone can register for free, but that also comes with a responsibility. So if you don't fix bugs, you're flagging. After a while, we would remove you from that blocking queue because you can't block a release for years if you given up on that. So what else is this industry doing? Now it gets even more messy into the reality. There are some speed dating events for tech where, let's say, 10 cars and 10 charging stations meeting, and every combination gets 2 hours together and see if things spark, literally. That's called then Testival from Charin, which is a big industry consortia. Similar things happen with backend system and charging station, and it's called OCPP Plugfest from the Open Charge Alliance. You often see prototypes there, and it's super, super helpful because having those different combinations, that really works. One fun anecdote, there was recently a new standard released from the Open Charge Alliance, version 2.1. We had been on a festival with our EVerest implementation. This was totally brand new code. We tested it and everything worked. Like, what the fuck is happening here? What we then realized, like, oh, they're all tested silently over the last weeks against our public GitHub. So we don't even have to come in certain situations because we kind of becoming the free open source counter test tool for the industry, which is really, really nice to see. Besides that, there's also commercial solutions from Vector, Comenzo, or whatever big hardware blocks which come with a software subscription, where you can also run a couple of, let's say, industry-maintained test cases. And I think EVerest complements that because we're not a dedicated test system. We're just, let's say, the productive code which you can also use for testing. What we're also now doing, or what the industry typically doing in IoT space is monitoring the things out there in the field, see if there are bugs, if there's issues. So from a bug reported to unrolling a firmware update in a canary way, so starting small, increasing fast. It's also good practice, so you have the feedback loop to the real productive world. We recently built a system which is dedicated for EVerest, so understands the log file, understands the EV charging specifica, but there's also a lot of generic IoT platforms out there like ThinkSpot. But also we are super happy that LF Energy recently sponsored the penetration testing for the EVerest project. It was done by Quarks Lab. I think it was over the last 6 months or so. Kai, who is also organizer of this energy dev room, worked intensively with them. So in principle, quite happy. Side anecdote here. The number one bug they flagged, like, oh, but you can copy RFID cards quite easily, and then you can fake anyone else in the room and behave, copy their charger account. Like, yes, we know that. It's a flaw in the standard. It's a bit like you can't be more secure as an implementation as the standards you're implementing are. And things like that popping up there, but also a few other things which have been useful and then responsibly fixed and disclosed behind the scenes before unrolling the report in the public. Another feedback loop we're now implementing is not only having the developer of EVerest in the community, in the different working groups, but also having the users. So like the ones who buying charging station, unroll them into the field and have to live with the stuff we're building here as a community. And that's just started, continues in 2 weeks from now. And the goal is really having the feedback loop on what criteria should the community focus on, what should be on the roadmap, what KPIs should you measure for, what do we expect from a good system to behave. So I think user groups are also a perfect way on a very slow compared to unit tests feedback cycle on your quality, but I think it's really crucial. Yeah, at the end of the day, sanitization is super, super slow. Often quoting this OCA standard here, just to give you an idea, I think the current standard 2.1 is out there since 2 years. The previous one is out there since 8 years. And the previous one has still 80% adoption rate. So everything happened the last 8 years plus is less than 20% in the field. So still, we try to be the first implementer of new things with the community, doing that really, really cross vendors. What we often see is one vendor is interested in a feature, then they go after it, another is interested in another feature. So community, we tie that together, and then at the end of the day, we hopefully have a really full and feature-complete implementation. And often we also see issues with the standard in that process, so we can cycle it back to the committees. Sometimes we got asked by the committees like, oh, this was not specified. How is EVerest doing it? Then we tell them, and they maybe go after that solution and put it into the standard. So I think it can be a really fruitful relationship. And the good thing is, if our implementation is ready as soon as they are ready with drafting, we can accelerate this 8 years before a new version is used, what I just quoted quite a bit. Yeah, that's it about EVerest. If you're interested in joining us, all the code is here. We have quite active chat space. We have a lot of also quite extended, freshly extended documentation out there. Different working groups. Every week there's a couple of different meetings for segments. Give us a ping, and if you have any questions, let me know.
4 minutes for questions. Thanks for the presentation. I know there's a lot to cover in this field. You didn't talk about the
interaction between the CPO and the interfaces that are client-facing. They are communicating with the OCPI, and is it something you are planning to cover in the few months? Or?
So I know what you're talking about. So in principle, going back to that picture, EVerest focuses on the charge in the middle. The charge point operators are in my symbol like the yellow dots here. And the protocols you're talking is kind of another layer behind this. So we're not going after that because this OCPI and all the testing on that, and it's the duty of another open source project. There's a few like Citrino OS and Linux Foundation, Maven and others out there, so they hopefully take care of that.
Just curious, what is the organization behind EVerest? Like, is it a company, a non-profit, or a community?
Repeating the question, so what is the organization behind the EVerest project? It's a company or community. So my startup started that open source project like 6 years ago, 5.5 years ago, donated it to the Linux Foundation like 1 year later or so. And since then we are given the Linux Foundation tools, like 600 people already touched that project, more than 80 organizations. So yes, my startup is still one of the drivers. We do quite a bit, but we are by far not the only one. And so I think in sum, we're not the biggest contributor. We are one of the big ones, but there's others which are in total way bigger than us. Does it answer your question? And right, how we organize, there's monthly technical steering committee meeting where the high-level political decisions are made in consensus. Then there's different working groups for, let's say, meeting once a week to discuss, go left, go right, how to do certain features. And then there's Zulip chat and GitHub interaction and pull request, and there's all the details then.
With how many EV chargers in the field is it now?
So it's super hard. So how many chargers are in the field with EVerest? Super hard to guesstimate because it's open source. You don't know who adopted it. Based on our best knowledge, it should be roughly 70, 60,000 right now. And we have a huge vendor who want to retrofit 300,000 chargers within the next weeks. So we will have, it was planned for end of last year, but everything is later, as you know. So we will have like 300,000-400,000 in some days.
And do you see these vendors actually supporting the maintenance?
Yeah. Not every vendor is supporting the maintenance, but some vendors do. And it's like, I can name some who are already public, like Alphen from the Netherlands contributed a lot to a certain library for a certain version. Now another vendor is picking up for the next version, helping there. Really, wherever someone is interested.
Do they then pay Linux Energy Foundation?
No one pays. No one pays.
The vendor pays for maintenance?
No one pays for maintenance.
Oh.
Their maintenance is like best effort. If you need something super rock solid tested, you maybe have to do it yourself or find someone helping you. So yes, I would do that in principle, but in general.
Like the business case of Pionix.
So the business case of Pionix, we help people to code missing features if they can't do it themselves. And we offer hardware modules which are compatible with EVerest, offering cloud solutions if they need something on top. But EVerest itself, we're not making money with that. Linux Foundation isn't making money. This is just more than 1 million lines of code by a lot of people built together.